video tutorial series of computer network subject. In this video, I will explain the IP addressing and DHCP concept with context of network layer. I am Jishan Sheikh, Assistant Professor in IT Department of LJ Institute of Engineering and Technology. So, when we talk about the network layer in OSI or TCP IP model, basically it provides the service of routing the packets from one host to next host. So, network layer contains many protocols. For example, ARP, RARP, IP. From that, I will explain here IP addressing technique and then after DHCP protocol. So, how exactly IP addressing is assigned to particular devices? So, for that, ICNA agency is available that assign specific public IP to our ISP. That public IP addresses is assigned to our organization or our devices. So that public IP address is available to throughout the internet. So how many IP addresses available in real time? If number of devices that are connected in real scenario with the internet, that all the contains IP addresses. So in whole world, how many IP will be generated? So for that constraint, we have to use different constraint that help us to understand the IP concept. So basically IP having two types, IP version 4 and IP version 6. So when we are talking about IP version 4, it contains 32 bits IP address, and if we are talking about IP version 6, it's having 128 bits. In this video we are considering the version 4. So when we are talking about the IP address, it contains the proper header format. In that header format, our packets will be encapsulate our particular data and transfer to the next router. We will understand here how exactly IP address is containing the network bit and host bit to identify particular organization or device. So when we are talking about the IP contains basically two parts. One part is network ID and second one is host ID. Host ID will identify the particular device, where the network ID will identify the particular network from where all the requests are coming inside and requests are going outside. For that identification, we are using different type of class type. That class type will define from which category we are using this IP. Now let's understand particular concept one by one. So when we are talking about the classes, the whole class will be divided into the broad 5 categories: class A, B, C, D and E. So from among 32 bits, class A having a first byte, or we can say that it is total, it consumes 8 bits for our network ID, and remaining 24 bits are used for the host ID. So my networks, so according to class A scenario, we can consume 2 raised to 24 hosts, where the network ID contains 2 raised to 8 bits. For the class B, we can see that it can use total 16 bit for network ID and remaining 16 bit for host ID. Whereas in class C, we can use total 24 bits for our network, and for remaining 8 bits we can generate the host. Class D and class E will uses for the purposes of multicasting and reserve for the future uses. So when we are talking about class A, we can see here first bit will be 0 always. When we are talking about class B, so first bit is 1, second bit is 0. When we are talking about class C, first 2 bit is 1 and third bit is 0. In class D, first 3 bit is 1 and fourth bit is 0. Whereas in class C, first 4 bits are 1. That will be calculated in the later part. But for the identification of class, we can use this particular concept. Now we are learning how the particular decimal notation is used to identify our IP. So if you are observe any IP address for your devices, you can see like this. There will be some decimal number contains a value from 0 to 9 with dotted notation. So here our particular 32-bit IP address is divided into the 4 chunks, each having 8 bits. So first 8 bit contains decimal number, second 8 bit also contains decimal number. That decimal numbers are relevant to our previous scenario that defined by the different classes. What type of class I will use, that will be identification of this particular 4 bits. So here the example 128.11.3.31. So from this binary number we are calculating the decimal number. So when we see any IP address in background, it will be calculated like this. So in real world scenario, we are seeing this type of IP addresses that contains decimal, but in the background it will be converted like this. So this is the basic idea how the IP address will be assigned to particular device and how we are seeing this particular IP. Now I am explaining the range of these particular classes. Okay, which type of IP addresses, which type of host ID and network ID assigned. So when we are talking about class A here, so we already see the first bit, the range of class A is starting from 0 to 127. So here first bit will be considered as a 0 according to the class. Okay, remaining first bit is our network ID and remaining 3 bits are our host ID. So total range, if we are considering from class A, it will be started from 0 and ending with 127. So range of total class A, we can say that it is a 128 bits, that is 0 to 127. Now we are moving to class B. So ending of class A is it is generated from 0 to 127. So class B will be started from 128. It will started from 128 and it is ending with 191. But according to the particular scenario, class B will use here 2 bits for our network ID and 2 bits, remaining 2 bits are used for host ID. For class C, range will start from 192 and ending with 223. Class D will use for 224 and ending at 239, and class E will start from 240 and ending with 255. So according to our whole case, it is starting from 0 and ending with 255. But our class A, B, C, D and E will specify specific range. According to that range, we can understand which IP address is assigning to which class. And that is possible for our classful addressing concept. If we are talking about classless, at that time we can assign any IP address to any class. So there is no meaning of this division. I can assign any IP address to any device. That formula or that concept is known as a classless. But when we are talking about specific range and we can understand from the IP address, that IP address is belonging to which class, that can be considered as a classful addressing. So this is the basic fundamental, what is the IP address, how the broad class category will assign, and what is the range of the particular classes. Now I am explaining next algorithm, or that is your DHCP. So DHCP stands for Dynamic Host Configuration Protocol. So why we are learning or understanding DHCP? So DHCP is allow host to dynamically obtain the IP address from the network server when it joins the network. So when we are talking about assigning IP to any device that are connected to the network, that will be two cases. First case is static. Statistically, if we are talking, if any network administrator is assigning some IP to particular device, so that is a static IP address. But how many times network administrator is assigned the particular IP address to devices? If that is a fixed scenario, that will be possible. But if periodically the number of devices are changed, then at that time, if we want to assign that IP address automatically, we can use this concept. So the basic fundamental of DHCP is allow the host to dynamically obtain the IP addresses. So what is the advantage or benefit of that? So we can renew the list of IP address in use. It allows the reuse of address, because once I assign the IP address to one device, after the completion of that task, that device is disconnected. So the same IP address can be assigned by DHCP server to new device. So there is no creation of new IP here. And it supports the mobile user who wants to join the network. So if the user are movable, one user is coming in the network, use the concept of our IP addresses and move to the next network. So when the user is moving, there is no possibility of assigning the static IP. So at that time, this is the very helpful concept. Now we will learn how the DHCP is working. So when we are talking about DHCP working, there is a four category. First is host broadcast the DHCP discovery, because if any device wants to IP address, first is join the network and discover for some DHCP server it is available or not. Now next, DHCP server is respond with the DHCP offer. If DHCP server is offering or available, it generate the availability, it can assign IP address or not, that will be a second part. Third one is host request for IP address with the DHCP request. So in this step, host is requesting for some IP. In the first step, DHCP server is sending the address with this acknowledgement. So ultimately, when particular client is enter into this particular network and wants dynamic IP, then these four steps will be followed one by one. Now understand this concept in this scenario. So when we are talking about some server, DHCP server, it is already enabled with our network administrator. Now different devices are connected with the different network here. We can see here one IP address range is 223.1.1.0 here. Okay, this connection having multiple devices with some specific IP address range. Now next one is our 223.1.3 range, and third one is also here. So when we are talking about to conversion our IP, we have to take care from which particular IP address range our data is moving. So when the particular client is requesting for the data that will be related to DHCP, DHCP server is check its needs of IP address and then assign the particular IP to relevant devices. So this is the basic architecture how the DHCP is assigning the IP according to the range of this particular device. Now we will learn the particular client server scenario of DHCP. So assuming that we have one DHCP server with 223.1.2.5 IP and one client is arriving in the network. So what the process is working behind that? So first, if client is arriving in the network, it broadcasts the message. That is the step number one. That is all about DHCP discovery. It is searching for some DHCP server that gives a IP to it. So broadcast the message. Is there any DHCP here with its original IP address and particular destination address with its MAC address? Now in the response, our DHCP is giving that I am available here with specific IP and that's destination address. Now that particular client in third step is requesting for DHCP and tell that I want one IP from you. And in the response, particular DHCP server is giving, okay, I have got an IP for you. So according to the acknowledgement, it will assign new IP for the particular this server. So this is the basic client server scenario for DHCP, how the client is entering into the particular network, how the IP for the IP address in first request, in the response DHCP is offering the data item with this help of this posted. Now understand this DHCP request according to this scenario. So how exactly the data is flowing here? Now let's see first DHCP server is performing this task and it will go to the UDP that is the available at the transport layer. So first here DHCP server is formulates the acknowledgement that containing the client IP address that have to assign. And IP address of this first hop of the router, from that the request is coming of the client. So here total encapsulation is performing here with the help of this particular packet. So encapsulation of DHCP server is performing with the frame forwarding to this particular client and daemons will be performed at the client side. And client now knows the IP address which will be available, which will be generated by the DHCP server, and it will move that package to its first hop address. Now next scenario we can consider that how that response will be generated here. So connecting the laptop needs an IP address and that first hop router address. So that will be already generated by our DHCP server, and DHCP request will be encapsulated here from the laptop and it will be transferred to this our Ethernet address and forwarding to this particular server. So this is the example how exactly our DHCP is working in real-time scenario. So in this video, I conclude about what is the IP address and how DHCP server is assigning IP to any device which connect to the network. So thank you for watching this video.